Assalamualaikum. My name is Aina Tasha binti Muhammad Aziz, S7050. Today we will present our numerical method report for chapter 2, question 2.3, which focus on solving a nonlinear diode circuit equation. The given equation is V e to the power of 0.5 V equal 5. Since this is a nonlinear equation, it cannot be solved using normal algebraic method. Therefore, we use numerical method to estimate the value of V. First, we rearrange the equation into a function form, which is f of V equal V e to the power 0.5 V minus 5. Our goal is to find the root where f of V equals 0. We use two numerical methods in this study, which are the Newton-Raphson method and the bisection method. For the Newton-Raphson method, we start with an initial guess of V0 equal to 0.0. This method uses the derivative of the function and gives faster convergence. After several iterations, we obtain the final value of V approximately 1.9172 volt. Next, for the bisection method, we use the interval from 1 to 2. This method repeatedly divides the interval into two parts until it reaches the root. It is more stable but slower compared to Newton-Raphson. The final value obtained is approximately 1.9175 volt. We also verify both methods using MATLAB and the results are consistent with the manual calculation. In conclusion, both methods successfully solve the diode voltage problem. Newton-Raphson is faster but depends on a good initial guess, while bisection is slower but more reliable. The final operating voltage is approximately 1.917 volts. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahdan binti Muhammad Azan, S72439. So now I explain to you how to solve question 3.5. So here, as you can see, the instruction given for question 3.5. So here is the question given, which is A, to estimate the humidity H at T equal to 7 minutes using the first third order Newton divide difference method and second third order Lagrange method. And B, to estimate the humidity at 7 minutes using both methods and compare the result. So now we go to the first question, which is using third order Newton divide difference method. So since the point is given T equal to 7, we need to find 4 nearest point, which is T equal to 0, T1 equal to 5, T2 equal to 10, and T3 equal to 15. So since PT equation is given, so we need to find MV naught, which is we get MV naught equal to 68.0. B1 we get 0.3, and B2 we get 0.0440, and then we proceed to find B3. Next, we will go to the B3. We get the value for B3 equal to negative 0.00147. And since we have all the value for B value, and we enter to VT equation, and we will get VT equal to 70.078 for T equal to 7. So here we move to the next question, which is use the order of Lagrange. So here VT equation is given, and for equation to find a value of L, so L is equal to a total product of T minus Tj per Ti minus Tj. So the condition here, I will not equal to J value, and if I equal to J, we need to cancel the equation. So like L naught T, the answer for L naught is negative 0.06640, and the value for L1 is equal to 0.672. Next, answer for L2 equal to 0.448, and last one for L3 will equal to negative 0.0560. So next, after we get all the L naught to L3 value, we set the value to the VT equation, and we will get the final answer for VT is equal to 70.78. And for t equal to 7. So for the next question, B, for comparison of result, we can conclude that Newton divide difference method are more easier to update when we have a new data added and more efficient for repeated calculations. And while Lagrange method, the formula is direct and straightforward and just suitable for a small data set. So that's all from me.
Hi, my name is Nu'athira binti Muhammad Amin. Arithmetic number S71339. I would like to present a group assignment for chapter 4. My grouping have been conducted to make a question 4.4 that related to abandoned control computation. An embedded controller must repeatedly solve a system of equations to update control parameters. The control parameters are represented by x1, x2, and x3. The system equation is given by, first equation is 8x1 minus x2 plus 2x3 equal to 20. The second is minus x1 plus 7x2 plus x3 equal to 80. The third equation is 2x1 plus x2 plus 9x3 equal to 31. Given the initial guess, x1, x2 and x3 is equal to 0. The question have to use two decimal places. The question is A. Solve the system using LU decomposition that clearly show the L and U matrix. L is represented as lower and U represent as upper. So the L and U matrix is lower and upper matrix. B is questions. Solve the system using the Jacobi method for 3 iterations. That means the iteration continuously 3 times. C question is compare the solution that obtained from both methods and comment on convergence strength of the Jacobi method. The hand calculation for question A is finding the U and the lower side of matrix. Before to find a lower and upper, we have to find the pivot using R1 and then finding R2 with R1 minus pivot multiplied by R1. So for upper matrix, 3 zeros are consistent on row 2, 1, 3, 1 and 3, 2. And then the first row of matrix on first row will be consistent from original matrix. And then the other side will be found using pivot and the calculation, the already hand calculation on the slide. For lower side matrix, the consistent zero will be on 1, 2, 1, 3 and 2, 3. And then the number 1 are also consistent on the hand calculation. This means will be on 1, 1, 2, 1, 2, 2 and 3, 3. The other side of matrix will be calculating using pivot. After that, on the hand calculation also, the answer show is x1 equal to 2.21, x2 is equal to 2.54 and x3 equal to 2.45. That's hand calculation are provided by my teammate. And then that's all the answer for question A. Question B, that have to be calculating using Jacobi method. The hand calculation are more easier than the LU decomposition. So on Jacobi method, the answer for x1 is 2.18, x2 is 2.15, x3 is 2.74. The answers are not going far away from the first method. The Jacobi method are easier and mostly fast be using to calculate this system. So the answer for question C is the Jacobi method demonstrates a clear convergence trend toward the exact solutions. Although minor difference remain after 3 iterations, the method is stable and reliable for this system. The straight diagonal dominant of the coefficient matrix guarantees convergence, making the Jacobi an effective numerical technique for solving the given system of questions. For MATLAB code, for question A is identify and key in the matrix A and B on coding, and then given instruction to LU decompositions, and then display the matrix L by using F prime matrix L's and the percents. After that, display matrix U, and then solve Ly equal to B. On that coding, Y equal to L divided by B, and then solve Ux equal to Y is X equal to U divided by Y. After that, display the solution on coding using F prime. On command window, I show the code value after include in using coding. The last but not least is coding for question B. In coding for question B, the coding written is x1 until x3 equal to 0. And then the coding follow with f prime iteration x1, x2, x3. And then for k, the equal to 1.3. So x1 new will be conducted as 20, x1 equal minus x2 minus 2x3 divided by 8. So the coding show how could be find. And then but last but not least, the command window show the answer for code B, the equivalent to the hand calculation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Muhammad Shukri. Today I will present the solution for question 6.5, which is about numerical integration. The given integral is the integration from 0 to 3 of in 1 plus x square dx. In this question, we are required to solve the integral using trapezoidal rule for n equal 1, 2 and 4. Apply Romberg's integration, compute the percentage true error, and determine which method is more accurate. For the answer A, we will use the trapezoidal rule. So the formula for trapezoidal rule is I equal to h divided by 2 fx0 plus 2 multiple summation of fxi plus fxn. So for the n equal to 1, h equal to 3 minus 0 divided by 1 equal to 3. Now substitute the formula I1 equal to 3 divided by 2 f0 plus f3. Substituting the function value I1 equal to 1.5 0 bracket 0 plus 2.3026. Therefore, I1 equal to 3.4539. Next, for the n2, h equal to 3 minus 0 divided by 2 equal to 1.5. Substitute the trapezoidal rule. I2 equal to 1.5 divided by 2 F0 plus 2 multiple F1.5 plus F3. Substituting the value, I2 equal to 0.50 plus 2 plus 2 multiple 1.1787 plus 2.3026. So therefore there will be I2 equal to 3.4950. For the N4, H equal to 3 divide minus 0 equal minus 0 divide by 4 equal to 0.5. So we substitute into the formula I4 equal to 2 I4 equal 0.5 divided by 2 bracket F0 plus 2 F 0.75 plus F 1.5 plus F 2.25 plus F3. So we simplify the I4 equal to 0.375 multiple 9.1568. Therefore the answer will be I4 equal to 3.4338. So this complete the answer A. Okay, next for the part B, we will use the rhombus integration. I apply a rhombus integration to improve accuracy of trapezoidal rule. Result: rhombus integration use the approximate obtained from n equal to 1, n equal 2, and n equal 4 in part A. This we will use this formula. So step 1 will R2 common 2 equal to R2 common 1 plus R2 common 1 minus R1 common 1 divided by 3. So we substituting the value, so it will be 3.4950 plus 3.4950 minus 3.4539 divided by 3. So the differences, it will be 0.0411. Okay, next 0.0411 divided by 3 equal to 0.0137. The final will be R2 common 2 equal to 3.4950 plus 0.0137. So the answer will be 3.5087. Step 2 will for the step 2, calculate the R3 common 2. So R3 common 2 equal to R3 common 1 plus R3 common 1 minus R2 common 1 divided by 3. So we substituting the value 3.4338 plus 3.4338 minus 3.4950 divided by 3. So the differences will be negative 0.061. So then negative 0.0612 divided by 3 equal to negative 0.0204. Therefore R3 common 2 equal to 3.4338 minus 0.0204. The answer will be 3.4134. For the step 3, final calculate R3 common 3. So R3 common 3 equal to R3 common 2 plus R3 common 2 minus R2 common 2 divided by 15. Substituting the value, so 3.4134 plus 3.4134 minus 3.5087 divided by 15. Difference will be negative 0.0953. So next, negative 0.0953 divided by 15 equal negative 0.0064. Finally, the R3 common 3 will be 3.4134 minus 0.0064. The answer will be 3.407. Therefore, the final rhombic integration result is 3.407. So we'll go to the question C. The true value of the integral is 3.4058. So the percentage true error formula is true value minus approximate value divided by true value. Multiple 100%. For the trapezoidal rule with n equal 4, the percentage true error is 0.822%. For the rhombic integration, the percentage true error is 0.0352%. So for the question D, the answer will be based on the calculation percentage true error. The rhombic integration method is more accurate because it has a smaller percentage true error. The trapezoidal rule gives an error of 0.8221%, while the rhombic integration gives an error of only 0.0352%. Therefore, rhombus integration provides a better approximate to the true value. That's all for my presentation. Thank you for the attention.